Wait a minute. Wait a minute, Bacon Mug. Are you telling me that you built a time machine of a 2010 Toyota Camry?
The way I see it, if you're going to make a time machine out of a car, you might as well do it with practicality and good sense.
You know, it's also funny that this happens to be the car that I drive.
Never mind that.
We're gonna have to back up, Bacon Mug. From here, we don't have enough road to get up to 88 miles an hour.
Roads? Where we're going, we don't need roads.
Wait, are you telling me this thing flies?
No, I asked you to meet me at the river because that's where we need to be. We're already here.
All right, Bacon Mug, so what do you think? This is your place. What's the best way in?
I designed the security myself. Entry will be difficult.
Where's our ticket?
Sheila. Who is Sheila? I'm not familiar.
Take too long to explain. Point is, she just might be our way in.
Of a wrinkle to what we talked about yesterday. So today's lesson and homework is really going to be pretty short, all in all. Seniors, if you're still watching any of this, stick with me through next week, or at least through the end of this week, because we've talked about that summation symbol, which has given some of you guys fits in the past. So I want you to have a sense of what it is before you take your ALEKS test, just in case you see it. So we talked about sequences yesterday and the notation for them. So what we're going to pay attention to here is we're going to describe or define a particular type of sequence that we call a recursive sequence. And all the word recursive means is when something looks back on itself in some way. We can use that word in lots of ways, but you see it in mathematics often. So we define a recursive sequence as a sequence where each term, each subsequent term, is defined using one or more of its previous terms. Now, don't worry if that doesn't make sense to you right off the bat. When we look at it here in a second, it'll make sense. The first key to a recursive sequence is that we always have to be given the first term. So if we take this example, if we say, okay, a sub 1 is -3. So our first term is -3. And here's the remainder of the recursive sequence. So a sub n is going to be equal to 5 times a sub n minus 1. Don't worry if that doesn't make sense. We'll illustrate it in a second. Anytime n is greater than or equal to 2. So in other words, after our first term, as we count up, then we're gonna look back one term before to work with. So let's see. So you can see right here, here's our 4. And let's see if we can figure out how we get there. Well, the first one's easy. A sub 1 is easy because they give us that one. So on your homework, it's going to be the same way. But what does it look like we do here? Okay, for every subsequent term, we're going to multiply the previous term. That's what a sub n minus 1. So in other words, if n equals 2 here, in other words, we're going to figure out what our second term is. 2 minus 1 means we're going to be working with a sub 1, which we have. So each time you're going to be looking back to the previous answer you just got. So 5 times a n sub 1, or I'm sorry, a sub n minus 1, excuse me. So, how do we do the second one? Well, what is a for 2? So a sub 2, 5 times a sub n minus 1. In this case, n is 2, so 2 minus 1 is 1. And we already have that value. We know that a sub 1 is equal to -3. And I am missing a piece here, very briefly. I must have written something down slightly wrong. Oh yeah. Turns out we also need -1 here. That'll make everything make a whole lot more sense. So 5 times -3 is -15, minus 1 more is -16. So now let's think what we would do with the next one. All right, well, what's a sub 3 going to be? Well, that means we need to know what the value of a sub 2 is, which we do. So 5 times a sub 2, which is negative 16. That's going to give us negative 80 minus 1 gives us negative 81. So hopefully this kind of gives you the rhythm of how it works. But just in case, and I'm sorry, this thing is making noise, so give me just a second. I'll be right back. So we're going to look at some examples here to try to illustrate a little more clearly what's going on. This first one's really very simple. So they give us the first term. A sub 1 is 7. And they tell us that the remainder of this recursive sequence is that for every a sub n, to derive that term, we're going to do 3 plus a sub n minus 1. In other words, 3 plus the previous term. Well, that one's pretty simple then. So for a sub 2, we already know a sub 1 is 7 because they give us that one. That's 3 plus what's going to be a sub 1. So 3 plus 7 is 10. Rhythm on this one's pretty simple now. So you're saying we're just adding 3 to every previous term, and that's basically what this means. Hopefully what I just did there makes sense to you. And hopefully what I just did there makes sense to you. Okay? 10 plus 3 is 13. We throw that one in the mix. 3 plus 13 is 16. And this one's a little more complicated, but still very doable. So they give us a sub 1 here. They tell us it's equal to negative 1. So remember, we always know our first term. We have to have a place to start. And they tell us that the remainder of the recursive sequence is a sub n equals whatever that n value is. Don't let that trip you out. That's going to be that sub number. Remember, that's what we plug in. That's our domain. And our terms equal our range. So whatever our current n is minus a sub n minus 1. So it means we're going to be working with the term that we're plugging in, but we're also going to be working with a recursive term as well. So don't freak, and I'm being imprecise in my use of the word term. I should be more specific about how I use it. So let's try it here. So a sub 2, okay? All right, well, what's that going to be equal to? Well, first off, what is our n? Well, our n here is 2, okay? 2 minus a sub n minus 1. In other words, whatever our previous term was. Well, we know that value. That's negative 1. So what is 2 minus negative 1? It's going to give us 3. All right, let's try the next one. All right, what's a sub 3? All right, well, to derive that, we take our n, which in this case is 3, and we subtract the previous term. Hey, which is also 3. So 3 minus 3 in this case would give us 0. All right, how about a sub 4 here? All right, well, let's go with our n. That's 4 minus a sub n minus 1. In other words, whatever our previous term is, that's 0. So 4 minus 0 is 4. Really pretty simple. If this doesn't make sense, come see me in live conferences. We can talk about it then. Remember, today will be live. Or later on this morning if you're watching it before live conferences. If not, and there's a recording to watch, you can go back and watch it afterwards. But your homework is going to relate to basically plugging in, keeping it simple with these recursive sequences. I want to wish you the best of luck with this, and I will see you tomorrow. I don't mind.